In this video, I'm going to discuss about the sampling distribution of the sample proportion. Now let's start from the population proportion. Population proportion is denoted as P, or sometimes it is also denoted by using pi. A population proportion is the percentage or fraction of the population that has a specific characteristic. The population proportion can be calculated by using P is equal to Y divided by N, where Y is the number of success elements in the population and N is the total number of elements in the population. Let's look at this example. Here we have a school SMK Permai. The SMK Permai has altogether 1,600 students. So in this case, SMK Permai is a population, and all the total number of the population in this school is 1,600 students. And among the 1,600 students, it is found that 100 students wear spectacles. So in this case, the specific characteristic that we are interested is students who wear spectacles. So the number of success element is the number of students who wear spectacles. So therefore, the population proportion of this special characteristic, that is the population proportion of the students who wear spectacles, is the total number of the success element, that is the total student who wear spectacles, divided by the total number of the elements in the population, that is 1,600. So the value of the population proportion can be written in the percentage form, or in fraction form, or in decimal form. So notice that the value of the population proportion is a fixed number because there is only one population. However, in real situation, the population size normally is very large, and it is very difficult to survey and collect all the data from every member in the population. So, the true value of the population proportion is normally unknown. So in this case, the sample data is used to estimate the population proportion. So means we are going to do the sampling. So if a random sample of size n is taken from a population, and from the n observation, if x is the number of success elements in the sample, then the sample proportion is equal to x divided by the sample size. So sample proportion normally is denoted by p hat. But sometimes different books can use different notation for this sample proportion. Now let's take this example of SMK Permai as the population with the population size is 1,600 students. Now I'm going to do the sampling where I'm going to select the sample from this population where the sample size is 50 students. Now from this sample, let's say if the student who wears spectacle is 8 students, So in this sample, the sample proportion is 8/50. Now if I'm going to take the second sample with the same sample size, so among these 50 students, if 4 of them wear spectacles, so the sample proportion for this second sample is 4/50. So when I repeat the process of sampling, I find that the value of the sample proportion varies from sample to sample, and it is unpredictable. So in this case, the sample proportion is a variable, and we call it as sampling variable. Now, if sample proportion is a variable, then what is the distribution of this sample proportion? Now, according to central limit theorem, the distribution of the sample proportion is approximate to normal distribution, but provided that the sample size is sufficiently large. If the distribution is approximate to normal distribution, then what is the mean and variance of this distribution? So from the sample proportion, we know that sample proportion is x divided by n, where x is the number of success element in the sample. So means x actually follows the binomial distribution, where P is the probability of success of each observation. So in this context, actually P is same as the population proportion. Now I'm going to find the mean and the variance of this distribution of sample proportion. So for the mean of the sample proportion, since sample proportion is equal to x divided by n, first I take out the constant. Then for this Ex is the mean of the variable x. Since x we know that follows binomial distribution, so mean of binomial distribution is equal to NP. So therefore, the mean of the sample proportion is equal to the population proportion. Next, for variance of sample proportion is x divided by n. First, when I take out the constant, it is 1/n squared. For variance of x, and x is binomial distribution, so variance for binomial distribution is NPQ. So when I simplify, it is equal to PQ divided by n. So therefore, the distribution of the sample proportion is approximate to normal distribution under central limit theorem, where the mean is equal to population proportion P, and the variance is P times Q divided by n, where Q is equal to 1 minus P. Since the sample proportion is a discrete variable and normal is a continuous distribution, so continuity correction is needed before using normal to do the approximation for sample proportion. Since sample proportion is x divided by n, where x follows binomial distribution, so means x only takes a discrete value. So when x is equal to 1, and let's say n is equal to 50, so the sample proportion is 0.02. When x is 2, then sample proportion is 0.04. When x is 3, sample proportion is 0.06. And when we look at the number line, so we find that sample proportion is only allowed to take this 0.02, 0.04 or 0.06, but the sample proportion is not allowed to take 0.03, 0.01, 0.05, or 0.035. So therefore, sample proportion is a discrete variable. When doing the continuity correction, let's say when the sample proportion is greater than or equal to a value A, so when we change to a continuous interval, the interval will start from a value slightly less than A, such that when pH is greater than the value A is included. So therefore, we are going to use the value of A minus a small value that is 1 over 2n. And for the sample proportion which is greater than A but not included A, then the interval must start from a value which is slightly greater than A, such that the A is not included. So we use A plus a small value 1 over 2n. Then if the sample proportion is less than a value included the value A, then the interval should start from a value slightly greater than the value A, such that A is included. So we use the A plus a small value 1 over 2n. Then for the pH, which is less than A, so the interval must start from a value slightly less than A, so that the A is not included. So we use A minus a small value 1 over 2n. Now after the theory, let's try some question about this sample proportion. Of the people who enter a large shopping mall, it has been found that 75% will make at least one purchase. A random sample of 200 individuals is chosen from the shopping mall. What is the probability that at least 160 people make at least one purchase? So in this case, the population is the people who enter the shopping mall, and the spatial characteristic is make at least one purchase. So in this case, the population proportion is 75%. Then we are going to find the distribution of the sample proportion. Since the sample size is sufficiently large, and based on the central limit theorem, the sample proportion is approximate to normal distribution with mean is same as the population proportion, and variance is PQ divided by N. So after simplifying, we get this one. Now the question is finding the probability that at least 160 people make at least one purchase. So in this case, the probability of sample proportion is at least means greater than or equal to 160 is the sample proportion, that is 160 divided by 200, so it is equal to 0.8. Then before we continue, since in this question we use normal distribution as the approximation and the sample proportion is a discrete variable, so we need to do the correction. So to do the corrections, since the sample proportion is greater than or equal to 0.8, where 0.8 is included, so under the correction, it becomes 0.8 minus 1 over 2n. So after simplifying, it is equal to 0.7975. Then after that, we are going to change the sample proportion into the z-score, where 0.7975 minus the mean 0.75 divided by the standard deviation. So after simplifying, we get 1.5212. So z greater than 1.5212 is equal to 1 minus z less than 1.5212. So from the table, z less than 1.5212 is 0.9358. Then finally, the answer is 0.0642. For this question, actually we have another method to solve. And we have learned that the proportion is very close related to the binomial distribution. If the population proportion is 0.5, this 0.75 is also same as the probability of success of each of the observation under binomial distribution. So therefore, x under binomial distribution, where x is the number of people who make at least one purchase and the n is 200, then 0.75 is the probability of success of each of the observation. And since the sample size is 200, which is sufficiently large, and NP and NQ is greater than 5, so we can use the normal approximation with mean is equal to NP 150 and variance is NPQ, which is equal to 37.5. And in this question, we are going to find the probability of the number of people who make at least one purchase is at least 160. So, since we are using normal approximation and x is binomial distributions, that is discrete variable, so we need to do correction. So we change 160 becomes 159.5. Then after that we change x to z score, and when simplify, then we get 1.5513. So z greater than 1.5513 is equal to 1 minus z less than 1.5513. So from the table, z less than 1.5513 is 0.9395. So finally, the answer is 0.0605. Now we move on. In an election, a candidate A received 47% of the votes. Find the probability that a random sample of 300 votes would have shown that majority of votes are in favor of candidate A. In this question, we are given the population proportion, that is 47%. First, we are going to find out the distribution of the sample proportion. Since the sample size is sufficiently large, which is 300, then under the central limit theorem, the distribution of the sample proportion is approximate to normal distribution. And the mean is same as the population proportion, which is 0.47. Variance is P times Q divided by N. So this is the distribution of the sample proportion. And we are going to find the probability majority of votes. Majority means more than half. Since we are dealing with the proportion, so majority we can use 0.5. So probability of majority of vote is the same as probability of sample proportion is greater than 0.5. Before I continue, I'm going to do the continuity correction. Since the sample proportion is greater than 0.5, which is not included 0.5, so I'm going to change the interval into a number slightly greater than 0.5. That is, I use 0.5 plus a small number 1 over 2n. Then I get the sample proportion is greater than 0.5017. Then I'm going to change the sample proportion into z-score by using 0.5017 minus the mean and divided by the standard deviation. Then I get 1.1001. Z greater than 1.1001 is equal to 1 minus z less than 1.1001. And from the table, z less than 1.1001 is equal to 0.8643. And finally, the answer is 0.1357. Next example. It is known that 64% of cars in Malaysia is national cars. Of the national cars, 25% is myvi. Find the probability that in a car park of 250 cars, there are at most 17% are myvi cars. So in this question, even we are given the proportion of the national cars, but our target in this question is myvi car. So the population is on myvi car. Then to calculate the population proportion of myvi, please do not directly take 25% as the population proportion, because from the question of the national cars, 25% is myvi. So 25% is part of the national car. So in order to take the population proportion, we should use 25% times the 64%, that is 16%. So the population proportion for myvi cars is 0.16. Next, we are going to determine the distribution of the sample proportion. Since the sample size is 250, which is sufficiently large, then the sample proportion is approximate to normal distribution based on the central limit theorem. And the mean of the sample proportion is same as the population proportion, which is 0.16. The variance is PQ divided by N. Then this is the distribution of the sample proportion for myvi cars. Now we are going to find the probability of at most 17%. At most means less than or equal to 17% is 0.17 of myvi car. And since we are using the normal approximation, before we continue, I'm going to do the continuity correction. And since 0.17 is included, so the interval should start from a value which is slightly greater than 0.17. So we use 0.17 plus a small number, which is 1 over 2n. Then we find that the interval is sample proportion is less than 0.172. Now I'm going to change the sample proportion into the z-score by using 0.172 minus the mean and divided by the standard deviation. And I get z less than 0.5175. And from the table, it is equal to 0.6976.